Welcome to 501 Matley, where we work smart, not hard. In today's problem, we're told that two towns, A and B, are located along the Appalachian Trail. At sunrise, Pat begins walking south from A to B along the trail, while simultaneously Dana begins walking north from B to A. Each person walks at a constant speed and they cross paths at noon. Pat arrives in B at 5 p.m. while Dana reaches A at 11:15 p.m. When was sunrise? Pause the video here, see what you can come up with. I'm gonna solve it this way. So first I'll begin by drawing a little diagram. We have point A and we have point B. B is directly south of A. Next, we have Pat and Dana. Pat starts at A and travels south. Dana starts at B and travels north. They are at the same place when it is noontime. Let's see. Let's let X be the time of sunrise. Let Pat's speed be P and let Dana's speed be D. Also, let's recall that distance will be equal to speed multiplied by time. So, we know that the time that it takes them to meet up will be 12 minus X hours, since we said that X would be sunrise and they met up at 12 noon. So 12 minus X would be the time that they were walking until they met. Now, Pat, she traveled from A to some place in between A and B where they met, and that distance, we don't know what it is, but we can say that it will be given by P times 12 minus X. And similarly, Dana's distance will be D times 12 minus X, which is their respective speeds multiplied by the time that they both were walking. Next, after noon time, then Pat continued on her journey and she traveled the rest of the way, which was the distance that Dana originally traveled. But since she arrived at 5 p.m., the distance that she would travel would be equal to P times 5. Dana traveled the rest of his journey, which is equivalent to the original distance that Pat had traveled before sunrise. But since he arrived at 11:15 p.m., that distance will be his speed of D multiplied by 11.25 hours. Now, since we know that the distances are the same in terms of what Dana traveled after noon and what Pat traveled before noon, we can then equate some of these expressions that we have. So we'll have that P times 12 minus X will be equal to D times 11.25. Similarly, the distance that Dana traveled before noon will be equal to the distance that Pat traveled after noon. So we can have that D times 12 minus X will be equal to P times 5. So currently we have two equations, but there are three unknowns, P, D, and X. Let's see if we can eliminate some of those. So let's start by taking that second equation and rearranging it to make D the subject and then substituting that into the first equation. So if we rearrange that to make D the subject, we'll have D equal to P times 5 over 12 minus X. Substituting that into our first equation, we'll have P times 12 minus X will be equal to P times 5 over 12 minus X times 11.25. Now, luckily for us, although this is one equation with two unknowns still, since we're multiplying by P on both sides, we can cancel those P's and just have 12 minus X is equal to 5 over 12 minus X times 11.25. Transposing that 12 minus X on the right hand side, we'll have 12 minus X times 12 minus X is equal to 5 times 11.25, which is 56.25. Expanding brackets, we'll have 144 minus 24X plus X squared. And then when we transpose, we'll have minus 56.25 is equal to 0. Simplifying, we'll have X squared minus 24X plus 87.75 is equal to 0. That is a quadratic equation which you can solve by using the quadratic formula, or in this case, you can factorize it. what two numbers would add up to a negative 24 but multiply to give you 87.75? Those two numbers would be a negative 19.5 and a negative 4.5. So we set x minus 19.5 is equal to 0, which gives us x is equal to 19.5 hours. But that is a solution that we will disregard. Why? Because remember, x represents the time that was sunrise. So if we got that x is 19.5 hours, then that would mean that sunrise was actually at 7:30 p.m. after noon. But we are told that they started out simultaneously at noon, and then when they were walking, they met together at noontime. The other answer we would get is that x is equal to 4.5, which in terms of real time would be 4:30 a.m. Did you get it right? If so, comment below. And as always, if you found this video useful or you liked it, please feel free to hit that like button, share with others, and subscribe if you're new here.